Hi, good morning. Welcome to this year's edition of PyData Eindhoven. My name is Julia, and I'll be one of the moderators for today. We're really excited to introduce Yannick Mariman and Harlley de Lima, who will be sharing their insights on scaling retail planning at IKEA, orchestrating sales, fulfillment, and capacity assessment with Metaflow. A couple of fun pet-related facts about our speakers today is that Harlley recently trained for the Amsterdam Marathon, confidently going for a personal record, until his dog gave him an unexpected bite on the nose, which he says for sure took at least 5 minutes out of his time. And Yannick is a big fan of South America, so much that he named his cat Palta, which is the Chilean slang for avocado. This is also his first time speaking at such a big conference like PyData Eindhoven. So let's give a very warm welcome to Yannick and Harlley.
Okay, hello everyone. Can you hear me well? Yeah, cool. I'm super happy to be here. So proud to present what we've been working on at IKEA. The name of our presentation is Retail Planning, Scaling Retail Plan at IKEA, Orchestrate Sales, Fulfillment, and Capacity Assessment with Metaflow. I bet most of you has at least one IKEA product at home. I hope by the end of this presentation you guys can have like an idea how this product could reach your home. But first of all, let's see if it works. Yeah, I'd like to introduce myself. My name is Harlley. I've been working for IKEA for 4 years. I'm a machine learning engineer. I help everywhere when it's needed at IKEA, data science, data engineer. Maybe you, Yannick, can you introduce yourself?
Yes, my name is Yannick Mariman. I'm working at Pipple, which is a data and AI consultancy company, and we're supporting IKEA with the forecast in the sales, fulfillment, and capacity area.
Cool, thanks, man. We always say that we work for IKEA, but I'd like to make a small distinction. IKEA has a franchisee system, and then Inca, it's the biggest franchise of IKEA. We are a super big company. We are a global company. You can see this by the number of sales, the number of co-workers that we have. And then we also we are present in more than 30 countries. So for example, all the stores that you see here in the Netherlands belongs to Inca. More than 30 countries. You can imagine that for us, that as data people, it can be super difficult to have a solution that can scale for the entire world. Super quickly about the Inca organization, we belong to the Group Digital. Group Digital, you can think about the tech people, the nerd people. Then we are belong to the fulfillment and the core service area. We are the fulfillment forecasting planning. To the right side, there is the retail guys, the retail planning team. You can think about them as people that work at the stores. They are super worried about the stock that they have at the stores. They are worried about how many of village shelf going to be sold in the coming year, if they have space enough at the stores to handle all these orders, all this product. So they are our users. So we create like system that make their lives easy, or at least we're going to try to do that, right? Okay, I'm going to explain a bit about the IKEA retail planning. Everything starts from the sales part. There is like people focus on the sales planning. So the planning you can understand as an estimation. So the sales planning, it's more like what's going to be sold in the coming year. So how many of a specific chairs going to be sold? How many of that lamp that are going to be sold in the coming year, for example? So they need to have like this estimation. And then they need to understand, of course, the previous sales. They need to understand like the market trends, the demand. Yeah, so they create this estimation, and then the next group, they are more focused on how we are going to fulfill these goods to our customers. So that comes to the fulfillment planning. So they have like, okay, how are we going to fulfill all these orders, all these products to my customer? So basically, if you live, for example, in Alkmaar, and then you buy a sofa, and then that sofa can be fulfilled by Amsterdam store or by Harlem store. So we need to decide to where those that sofa are going to be fulfilled from. Not only that, they need to know how that the goods going to be delivered. How, I mean, IKEA used to be like a cash and carry company, used to go to the store, the customer used to go to the store, buy the sofa or buy the lamp, all the goods, and then they bring back to their home. But nowadays, it's completely different, right? So you can buy it online, and then you can request a delivery, or you can also buy it online, and then you can pick up at the store. So those things are completely different now. So they need to understand where those products are going to be fulfilled from and how. And then the last part of this chain is the capacity plan. It's super complicated. I expect about the capacity plan, but for the sake of this presentation, let's think about this as the space needed in the stores. So the fulfillment plan, they create like the fulfillment estimation. So, and then they give to the capacity plan, and they said, okay, do I have a space enough in my store to handle all this fulfillment, all these orders? Or do I need to change the layout of my store, or make it bigger, a room bigger in order to fulfill the goods? Yeah, you can imagine, for example, in Christmas, there are some regulations, but most of the time they can also use the elevator to put all the orders inside the elevator. It's not ideal, but sometimes it happens because they don't have space enough. So as you could imagine, all those plans are connected. Sales plan is connected to fulfillment plan, and fulfillment plan is connected to the capacity plan. Or at least it should be the case. So our team, we are a cross-function team. We have like back-end, front-end, and also data people. So we thought like that we could help the users with our inputs. So for example, our users, they were like, their solution was distributed across different systems, and they need to do a lot of manual steps. So we thought, okay, maybe we can reduce the manual interactions to the system they use. If we connect the plans, and then if a planner or our user change the sales plan or the sales planning, that change can propagate to the fulfillment and also to the capacity. So if we connect that can lead us to fast adaptability. And also back then, they don't use data to have insights. So we also provide our users plans that are based on data, not only in human decision. Of course, the human decision play the important role here, of course, because we just give like them some insights so they can check if it makes sense or not. So back then, that was the whole process that we have. The planners, they are responsible, again, for the plan, for the sales, fulfillment, and capacity. They have some business goals in mind. They also have word information in their mind, and they are super knowledgeable people, super experienced people. So then they create sales and fulfillment and capacity plan. Yeah, there is no connection between those, not explicit. But we, as data people, we'd like to give them some data insights. So then what we did, basically, we create some features about the word information, and then we model this in our data set, and then we create the sales forecast, like the estimation how many goods going to be sold in the coming year, for example. And this sales forecast, it's an input for the fulfillment forecast, how the goods going to be delivered to the customers. And then the fulfillment forecast is now also connected to the capacity forecast. So in that case, we connect all the planning process, or at least the planning forecast, and then we give back to our planners. So then now, they can create the sales, fulfillment, and capacity, and these plans are potential connected. Cool. So we create a dashboard. From the previous presentation, sometimes dashboards are not that useful, but I hope this one is. But then, yeah, we create a dashboard. We work together with our backend and frontend. They create this. It's a full customized dashboard. The users can play around with this. they can select in the top. It's a bit difficult to see. It's way to the top. They can select sales, fulfillment, and capacity. In this case, you are seeing here like the sales dashboard. So basically, they can create like check like market area. So I'd like to see what's going to be the sales for the coming year for Eindhoven area, Amsterdam area. They can select. They can select product area, the category of products. They can want to see like the forecast. They can also see like the net revenue, gross revenue, and gross quantity, for example. So they can play around with these. Of course, they can see in the graph, like in pink here, it's the actual of the previous years. In blue, it's the actual of this year. And the line, it's the forecast. We also have like tabular, because we have so many users, they prefer to see the graph, but sometimes they want to do some adjustment in the tabular form as well. Cool, but I'd like to focus more now in the data science part of our solution, go more into detail about that. First of all, I'd like to talk more about like our data science staff. Our data science team, it's grouped into three different product teams. As you can imagine, you have like sales team, fulfillment team, and capacity team. Typically, these teams consist of 2 data people. I work together with this guy. And that can be machine learning engineer, data engineer, or data scientist. But what I would like to highlight here, that half of the data people that we work together, they are more science-oriented. So they don't want to be bothered by, I need to adjust the infrastructure, I need to work with these engineer tasks. They are super focused on the science. That's going to make sense in the follow slides. So back then, we were like a small team, and then we have like a landscape. The landscape, it worked for a while, but then we saw we faced some issues that we would like to overcome. And then our team was also growing. So we decided, okay, the whole solution, the issues with the landscape, it's like the whole solution was distributed across multiple repositories, and those repositories were lacking standardized structure, which lead us for high maintainability, as you can imagine. The complexity is too high that it's super difficult to test a simple feature to our model. It's super difficult to get to test that feature with the whole data set. Each team needs to share their own resource. For example, if I want to test a new feature, I used to call Yannick and ask him, can I use the DAG now, or are you using the DAG? And then we have to do this, and then it's super difficult to work like that because it's low down our development speed. And also back then, we didn't have any orchestration tool for this part here to connect sales, fulfillment, and capacity. So one moment we gathered together and thought, okay, we need to have a better landscape for us. It's not working anymore. So then we thought a common consistent framework across team should help. But this framework should be simple enough to boost the data science productivity, those people that want to focus more in the data, should be able to scale for more than 30 countries, should reduce the complexity of our landscape, should provide isolation environment for experimentation, and also should integrate sales, fulfillment, and capacity solution. Now I give the floor to you, my friend, and explain them how we solve this.
Yes, so my colleague just explained that we have 5 main struggles that we had in our previous environment. I'm going to tell you how we tackled these challenges a little bit later, but first I want to let you guys meet Metaflow, which helped us solve these challenges. Metaflow is a data orchestration tool, which means that the tool handles the scheduling, the parallelization, and eventually the resource handling. It's a data scientist-friendly tool, as Harlley already indicated. It's made in mind for data scientists to do machine learning, to do AI, and not be bothered by things that you don't want to work at. It's a Python package, which is open source. We already talked about that in the keynote, which is great, and it's free, which is also really great. Where it came from is that Metaflow was being used at Netflix internally, and they want their data scientists to be busy with machine learning. Just before 2020, they thought, whoa, this tool works quite great, let's open source it. And then at one point it got a lot of traction. So other big companies started using it, did feature requests, they asked for support. Netflix wanted to focus on their core business. And then the two creators from Metaflow inside Netflix, they said, yeah, let's start our own company, which is called Autobounds. And they now, Autobounds supports Metaflow. They do feature requests, they have an enterprise layer, etc. So that's what Metaflow is. And yeah, also for the managers, I don't know if the managers here, you want to keep your data scientists busy with what they're proficient at. So if somebody is good at something, you want them to do what they're good at and not do what they're not good at. Data scientist power is not in the Kubernetes resourcing, it's not in orchestration. So Metaflow abstracts this layer. Okay, a little bit intangible until now. So one of the things that Harlley also mentioned is that if we change our framework or our way of working, that it needs to be simple. Okay, Metaflow is Python code. It's written a little bit differently, but it starts at the start. And at the end of the start, you have the self.next step, which indicates what the next step will be in your workflow. So here it says self.next, self.modeling. So the next step would be the modeling step. So in the modeling step, we have the self.next, self.end. Well, I guess you guys can imagine what the end step does. It's the end. So in this way, it's really easy to understand where does it start, what is the next step, and what is the last step. So it gives also a little bit more tangibility at how a flow works throughout the Python code. So in core, it's quite simple, but next to being simple to read, it also should be simple to develop in the code. We talked about that we develop for more than 30 countries. We have the data. That amount of data is not, we cannot use it on our local machine, of course. So one of the powers of Metaflow is that it's really easy to, from your local PC, to put it into the cloud. In this case, you only need one command line, which is the Python forecast pipeline Argo workflows create. And then your code that's being used locally, you can run it into the cloud, which is really easy, and you can handle all kinds of data sets. So sounds almost too good to be true. So how does Metaflow work? It gives a little bit more how it works. So development phase, translation phase, and execution phase. Development happens, like most of you are familiar with, AR IDE, VS Code, PyCharm, or whatever you like. You see the code a little bit written differently, as we saw previously. So in the translation phase, that's where Metaflow shines. Metaflow reads the steps, the start, the end, and it creates a DAG, a directed acyclical graph, which shows how the workflow will go. In the Metaflow code, you can also specify all kinds of other things, such as resources, such as configs, parameters, artifacts. Everything can be defined inside the Metaflow code. And then Metaflow, in the translation phase, it translates the Python code to another file format. The file format can be a little bit different depending on the executioner. The executioner can be local. Metaflow also works local, and then we're talking about subprocess. Or you can do it in the cloud. Metaflow works really good with Argo workflows. Also works with AWS, Airflow. I guess it's the orchestrator most of you are familiar with. And in the execution phase, resources are being handled. Kubernetes pods are being spun up, spun down. So maybe to clarify a little bit, Metaflow's power is to shine in the develop and the translation phase. The execution phase is actually not being handled by Metaflow, but if you use the cloud, which is where Metaflow shines, you need that part, and it's also depending on the execution part how it performs in the translation part. I'm not going into deep why we've chosen Argo Workflows over Apache Airflow, but a small note on Argo Workflows. Argo Workflows is a Kubernetes native orchestrator, which means that it works in the Kubernetes ecosystem and is also really good working together with all the Kubernetes features. Which means that if you have role-based access control, if you're having secrets, configs already inside your Kubernetes environment, Argo Workflows works directly with them. Also because it's working directly on the Kubernetes layer, there is not a lot of things in between, and scaling is really easy. So what does it look like in practice? So we have here a piece of code to the left, which is the develop side, and to the right, which is Argo Workflows, where you can see that the code really transforms to a DAG, as you can see on the right side. One of the most easy and interesting things here is in the red block, that's why I put a red block there, is that you have the self.next, the next step, and then for each country. As we talked about previously, 30 countries, it's a lot of data. Even for the cloud, it's a lot of data. So it parallelizes really easy. You can see it at the right bottom where you see the split. So it's quite good at scaling. Also, one of the things that we wanted is to reduce complexity. We had different teams which have all kinds of repositories, and you see here that the complexity that in the Metaflow code, the modeling, the orchestration, versioning, it can all be put together. So in the previous setup, we had 8 repositories which were handling the sales fulfillment and capacity part. In the new setup with Metaflow, we were able to boil it down to 4. To be honest, it's not only Metaflow, we did also some other stuff, but this means that there's a lot of less overhead. In the previous setup, if we wanted some changes in the capacity repository, we had to change the capacity repository, we had to change the base image, and we had to do the DAG. That's 3 pull requests for one feature. People that review pull requests immediately can think that's no way to work. In the new setup, we have everything inside the capacity repository, or everything inside the sales repository. So that helps a lot. This is one of the favorite things. Harlley is a really nice guy, as you maybe have noticed, but I prefer not to call him several times a day. So isolation is one of the key features which Metaflow has as well. That means that you can develop in the cloud at the same time. We don't have to see if somebody is using certain DAGs at one moment, and things are being, boiled down together in namespaces. It's slightly different with Kubernetes namespaces. In this namespace from Metaflow, the results and the data are being organized together. So this is really convenient. Production, test, development, everything can run at the same time. One of the last things that we also found important was the integration between the teams. This is a small feature, but also noticeably, we wanted the teams, the workflows to work in tandem. And in this case, we could do that with the trigger on workflow command, or decorator, I have to say. And the power here lies is that you only need the name of the previous workflow, and they don't have to be in the same repository, they don't have to be anything, just in the name, then in a translation file, it gets put in as a trigger. So that's the power of the integration part. So we talked a little bit about the challenges that we had. Simplicity drives productivity. We try to be simple with the code. Things should be understandable. Simplicity, one pull request should contain one feature. We were able to iterate much faster. A framework that strengthens collaboration is awesome. It's really nice to work in a nice way together. More people that can review pull requests work together. It's a really nice way. and design your machine learning frameworks to scale. You saw how easy it was to scaling. On top of how easy it was, we were also able to boil down some computational pipelines, which took over 7 hours to only 1 hour, because Metaflow was really that fast. We like Metaflow. Not everybody should be able to like Metaflow, but we want to say, really take into mind what are the challenges your team has, how can you tackle them, and find a solution for them. It makes it easier to work together, but it also makes it more fun to work together. We didn't do this ourselves. Harlley and I are obviously smart guys, but we did it with the 8 of us. So teamwork makes the dream work. And in the IKEA way, I want to say, tak, thank you for listening. And if you have any questions, feel free to raise your hand.
Thank you so much, guys, for the presentation. Are there any questions?
Thanks a lot. Thank you for the crossover episode. I was at PyCon Sweden last month. I was disappointed that there were no IKEA talks there, but at least I got one here. So, quick question. From my perspective, some of the problems you're having, they're more traditional math programming or operations research problems, right? How do you, and if to what extent, combine these two, right? I mean, ML ways with traditional optimization ways. Is there any correlation or overlap between those two?
If I understand correctly, you're asking if we also use more OR solutions.
Okay. Yes.
Yeah, we don't use it at in the sales fulfillment capacity. We more give insights and try to also give prescriptive insights. There are other teams where they do more OR, such as the teams where they try to decide what should the cost be of what should the cost be of home delivery, of store take, etc. So we do have those at IKEA, just not in our team.
Yeah, but it's super good question. When we start the project, then we were a lot of discussion, like should we optimize, do some optimization here or there. For example, the sales, our users, they want to play with the promotion. So they want to have like a target in mind. And yeah, there's a group of people that say, okay, we need to sell this amount. How can we reach that amount of money in sales or revenue? So then we can have like some scenarios that you can boost like the sales. So for example, discount in parking lot, for example. So there are some discussion about that. And also sometimes we want to flow for the fulfillment part, you want to optimize the way that we do deliver. So there is also a scope for that. But what we discussed together with our product team, that this could lead more valuable for them for now, but there are a lot of scope for this as well in your team. Thanks for the question.
Thank you. So thanks for the presentation. It was really nice and also quite insightful. You have a really nice linear pipeline in terms of the different processes that you're trying to predict on. Of course, there has to be some sort of an layer that interconnects the two, where, of course, you have the dependency before and after. What are some lessons learned in the development of such a pipeline that you are describing now, and lessons learned especially regarding those interconnecting layers?
Yeah, that's also another good question. It was super difficult for the data perspective how we should connect this. We are still debate about that. First of all, we as a data scientist, we thought like this forecast should be disconnected in the first moment, because we thought like, yeah, because if I don't have, because sometimes this connection can be like a constraint, you know? So then if you connect, we might lose in accuracy. And then we were, especially myself, I was super angry at that. But then I talked to the product team, and they said, okay, I know what you say. I know a bit what you're saying about the accuracy of your models. I know that you care a lot about that. But I think for our users, I think we're going to deliver a feature that is going to bring more value to them if we connect them. Even though if the forecast can be a bit like the accuracy can be low, a bit, not that much, of course. But then I think for me that there was like a lesson that I learned during this process, that it's super cool to connect, but yeah, you might lose in some aspect. And also we need to give them, to the users, the ability to adjust, because then if the accuracy is not that good enough, they can adjust in every way. For example, you can also may think that the fulfillment part can affect the sales, because we can have like a huge target, but I don't have people enough to do the fulfillment part. So they need to come back to the sales and say, hey guys, that's not possible to sell like those amount of products because we don't have capacity here. So this is more like a back and forth. So you have to open the mind as well.
Thank you so much, Harlley, for the answer. We will have to stop here due to time constraints, and we will have a 15-minute break. But thank you so much for the talk. We were really happy to have you today, and a warm applause for our two speakers.